The concept of invisibility has captivated humanity for centuries. From ancient myths to modern science fiction, the ability to vanish from sight has been a source of both fascination and fear. For centuries, this power has remained firmly in the realm of fantasy. But now, thanks to groundbreaking advancements in science and engineering, the dream of invisibility is inching closer to reality. While achieving the complete magic wand-waving invisibility depicted in fiction remains a distant goal, scientists are making remarkable progress. They are developing technologies that can manipulate light and render objects partially invisible. These advancements open up a world of possibilities, not just for covert operations and military applications, but also for fields like architecture, design, and even art. This journey into the science of invisibility begins by exploring the core technologies driving this progress: metamaterials, active camouflage, and quantum stealth. Each of these approaches utilizes different principles to manipulate light and achieve varying degrees of invisibility. Let's delve into the fascinating world of these cutting-edge technologies and explore the potential they hold for making the invisible visible. Invisibility, at its core, is not about making an object disappear into thin air. It's a fascinating concept that has intrigued humans for centuries, from ancient myths to modern science fiction. Instead, it's about manipulating light, the very essence of how we perceive the world around us. Light is the key to visibility, and by controlling it, we can alter our perception of reality. To understand invisibility, we need to understand how light interacts with matter. This interaction is fundamental to everything we see and experience visually. When light strikes an object, it can be reflected, absorbed, or transmitted. These interactions determine the color, brightness, and visibility of the object. The way light behaves upon contact determines how we see the object. For instance, the texture and material of an object can significantly affect its appearance. For example, a red apple appears red because it absorbs all colors of light except red, which it reflects back to our eyes. This selective reflection is what gives objects their distinct colors. To make an object invisible, we need to find a way to prevent light from interacting with it in the usual way. This involves advanced techniques to manipulate light paths. Instead of being reflected or absorbed, the light must be redirected around the object, effectively making it seem as if the object isn't there at all. This redirection is a sophisticated process requiring precise control. This is the fundamental principle behind most invisibility technologies. By bending light, we can create the illusion of invisibility. This bending of light is a complex process, but it is achievable through innovative materials and techniques. Scientists and engineers are continually developing new methods to enhance this effect. In the following sections, we will delve into the specifics of how metamaterials, active camouflage, and quantum stealth technologies are pushing the boundaries of what's possible in the quest for invisibility. These cutting-edge advancements are not just theoretical but are being actively researched and developed. The journey to achieving true invisibility is ongoing, and each breakthrough brings us closer to turning this age-old dream into reality. Stay tuned as we explore the science and innovation driving this fascinating field. Metamaterials are artificial materials engineered to possess properties not found in nature. These materials are not just a product of simple chemical composition, but are meticulously designed to achieve extraordinary capabilities. These supermaterials are created by structuring conventional materials in intricate patterns at a scale smaller than the wavelength of light. This means that the arrangement of atoms and molecules is so precise that it can manipulate light in ways that natural materials cannot. This meticulous design allows metamaterials to interact with electromagnetic waves, including visible light, in unique and controllable ways. By controlling these interactions, scientists can create materials with properties that seem almost magical. One of the key properties of metamaterials is their ability to exhibit a negative refractive index. This is a groundbreaking discovery because it opens up a whole new realm of possibilities in optics and photonics. Refraction refers to the bending of light as it passes from one medium to another, like from air to water. This is a common phenomenon that we observe in everyday life, such as when a straw appears bent in a glass of water. Most naturally occurring materials have a positive refractive index, meaning they bend light in a specific direction. This is why lenses and other optical devices work the way they do. Metamaterials, however, can possess a negative refractive index, causing light to bend in the opposite direction. This counterintuitive property can lead to the development of revolutionary optical devices. This unusual property allows metamaterials to act as invisibility cloaks by bending light around an object, effectively making it invisible from certain angles. Imagine being able to hide objects or even people from view, just like in science fiction. Imagine a rock submerged in a stream. The water flows around the rock, creating a disturbance in the flow. The water flows around the rock, creating a disturbance in the flow. This is similar to how metamaterials can manipulate light to flow around an object. Metamaterials in essence aim to do the same with light, creating a disturbance that steers light around an object. This could lead to the development of new types of lenses and other optical devices that are far more advanced than what we have today. While the technology is still in its early stages, the potential applications of metamaterials extend far beyond invisibility. They could revolutionize many fields, from telecommunications to medical imaging. Scientists are exploring their use in everything from high-resolution imaging and super-fast optical computing. These advancements could lead to faster and more efficient data processing and communication systems, to creating more efficient solar cells and antennas. By improving the efficiency of these devices, we could see significant advancements in renewable energy and wireless communication technologies. Active camouflage takes a different approach to invisibility, focusing on blending an object with its surroundings rather than making it completely disappear. This technology relies on cameras, projectors, and sophisticated algorithms to capture the background environment and project it onto the object being camouflaged. Imagine a chameleon, seamlessly changing its skin color to match its surroundings. Active camouflage aims to achieve a similar effect by continuously analyzing the surrounding environment and adjusting the projected image in real time. This creates the illusion that the object is part of the background, effectively rendering it invisible to the naked eye. While the concept sounds simple, the technical challenges are significant. Active camouflage systems require high-resolution cameras, powerful projectors, and sophisticated algorithms to process visual information and adjust the projected image seamlessly. The system must also be able to adapt to changing lighting conditions and movements to maintain the illusion of invisibility. Despite these challenges, active camouflage has made significant strides, particularly in military applications. Several countries are developing active camouflage systems for tanks, aircraft, and even soldiers, allowing them to blend in with their surroundings and gain a tactical advantage on the battlefield. Section 5. Quantum stealth. Fact or fiction? Quantum stealth is a more enigmatic approach to invisibility, shrouded in secrecy and met with a mix of excitement and skepticism. This technology has sparked the curiosity of many, leading to numerous discussions and debates about its potential and feasibility. Developed by hyper-stealth biotechnology, this technology is claimed to render objects completely invisible by bending light around them using a thin, lightweight material. The concept itself sounds like something out of a science fiction novel, yet the company insists that it is very much a reality. The exact workings of quantum stealth are proprietary, but the company claims that the material manipulates light in a way that makes it impossible for observers to see the object behind it. This manipulation of light is said to be so effective that it can hide objects of various sizes and shapes, making them appear as if they have vanished into thin air. Unlike metamaterials, which often require specific wavelengths or viewing angles, quantum stealth is purported to work across the visible spectrum and from all angles. This means that no matter where the observer is standing, the object remains hidden, adding to the allure and mystery of this technology. However, despite the bold claims and intriguing demonstrations, quantum stealth remains largely unverified by the scientific community. Many experts are calling for more rigorous testing and peer-reviewed studies to validate the company's assertions. The lack of peer-reviewed studies and independent verification has fueled speculation and debate about the technology's true capabilities and whether it lives up to the hype. Skeptics argue that without solid scientific evidence, the claims of quantum stealth should be taken with a grain of salt. While the future of quantum stealth remains uncertain, it highlights the intense interest and ongoing research in developing advanced invisibility technologies. Researchers around the world are exploring various methods to achieve true invisibility, and quantum stealth is just one of many promising avenues. Whether it ultimately proves to be a revolutionary breakthrough or a case of overblown expectations, quantum stealth has undoubtedly captured the imagination and fueled the quest for the ultimate cloaking device. The journey to perfect invisibility continues, and only time will tell if quantum stealth will be a part of that future. The journey toward achieving true invisibility is fraught with numerous challenges. Scientists must overcome significant technological hurdles, including creating materials that can bend light perfectly. And it's not just about the technology, ethical and practical considerations also play a crucial role. How do we ensure this technology isn't misused? These are the questions that researchers must grapple with as they push the boundaries of what's possible. The idea of invisibility presents a fascinating dilemma. On one hand, it holds immense potential for positive applications, such as in medicine and defense. On the other hand, it raises serious concerns about privacy and security. Imagine a world where invisibility could be used for surveillance or even criminal activities. Balancing these possibilities with the risks is a complex task that society will need to address. The possibilities that invisibility technology brings are almost limitless. From revolutionizing industries to enhancing personal privacy, the potential benefits are vast. But of course, with great power comes great responsibility. Concerns about the misuse of invisibility technology are valid and must be addressed through thoughtful regulation and oversight. It's a delicate balance between innovation and control. As we stand on the brink of a new era, the advent of invisibility technology promises to be a paradigm shift. It's an exciting time, filled with both opportunities and challenges. The future holds the promise of advancements we can hardly imagine today. But let's not forget, with every leap forward, we must tread carefully to ensure that this powerful technology serves the greater good. The journey ahead is as thrilling as it is uncertain.